So now that we have looked at the architecture and how we want to deploy the plan for deployment, so this is the repository we have under this organization, Defensive Works. This is an empty repository now. We do not have any branch protections right now because there's no code in yet. What we do now is this is the actual code. We will initialize git init followed by, we have a simple readme, which we can, yeah, this is a simple readme. We will quickly add this. We'll make sure, yes, okay. Push the main. So this will push the code here. What we can do now, well, actually, before we create the branch protections, actually we can do that later also. This is to create the branch protection. Go here, go to branches. So add a branch protection rule. We have main as the branch protection. Require a pull request, which is what we want. And also, we do not allow any bypassing. So the above settings will apply to administrators and customers. So I don't think if I have that permission for my role because I'm an administrator. So let's also enable that. Allow users with push access to delete matching branches. Okay, can we create? Quickly add that. Quickly fix that. So what we have done now is created a branch protection rule for the main branch. We require a pull request before merging to the main branch. We require at least one approver for which we have another user, part of this organization. We also do not allow bypassing because an administrator could have that capability. We also allow deletion. So we do that, we're good to go. Next time we push code, let's say we want to add a license, git add license, let's say license, and we want to push, we get this error, which is good, which is what we want, right? So what we do is we create a branch, let's review one, check out that branch. Now we can add license as a part of it already. I guess so. Now if we do, yeah, I think that's it. We come here, get a pull request. Yep. So one file is the license. We can't make this change because we are not an approver. What we can do is we have another user for this purpose. Before we log in as that user and approve these changes, what we do is we can push rest of the code. Git status, what we do is also git add the GitHub workflow. So a quick look at the workflow, which I've been talking about, is so this workflow for GitHub is what we looked at during. So whenever there's a pull request for the main branch, we go ahead and run this, which uses an OIDC provider, which assumes the role. So the GitHub workflow runner will assume this role in this account, and which has this capability to validate policies and assume that role and then run this shell script, which is in the tests folder, which actually just runs AWS Access Analyzer valid policy with the service control policy as the policy type, and then run it against the files in that folder. So that's pretty much it does. And if it has any findings, so it lists out. So the way it runs is, so just to give you how it looks when it actually runs. So go into policies. So we have two policies here. Deny ability to create IAM policies. So what we say is we deny the ability to create an access key or create a user. The other policy is basically denying regions. So we restrict access to only specific regions with where we operate in, with the exception of a specific role which we can use to browse other regions. And also we mentioned the global services. For instance, IAM is global service, budget, health, like there are other services which are global services, Shield, CloudFront, Trusted Advisor, whatnot. So these are all global services. We have also added some of the security services. If you look here, which if we want, we can add it. If we want to enable it in other regions, even though we do not allow access, we'd still want to enable it in other regions. So if we want to do that, we'll have to allow it here, part of this service control policy. So the way to run Access Analyzer against any type of policy is, say, Access Analyzer. So this is the syntax of the CLI. So we run AWS Access Analyzer, validate policy type of service control policy, and then we give the policy document. So in this case, if we do this, let's quickly assume a role. Let's assume this role. AWS Access Analyzer. So it does not give any findings now because this is obviously it doesn't have anything wrong with it. To simulate something wrong, let's say this row, so this policy, we can actually have IAM, say, pass row, and it will still not spit out any findings, warnings, errors, whatnot. Well, if you want errors, we can. So this is an actual JSON error, JSON syntax error. So there you go. So that also covers. But if we want to simulate an actual error, because this is a service control policy, and also because we have deny here, I think even if we say change this to allow, I don't think, because it's a service control policy, it will not spit out any error. So, but if we change this to an identity policy, so Access Analyzer has capability to validate 3 types of policies: identity policy, resource-based policy, and service control policies. So service control policies, you know what it is. We've already looked at. Identity policies are the usual IAM policies, which we attach to any user as a role. And resource-based policies are policies which we attach to, say, an KMS key or an S3 bucket. So those are resource-based policies which we attach to specific resources in a specific service. So for now, if we want to generate an error, now that I've added the pass role and I wanted to run this as an identity policy, if you're going to attach this as an identity policy, if I run this, it's going to complain saying that this is a security warning. You do not want to have pass role with star in resource. So that's a big no-no. And it also gives a suggestion that this is overly permissive. You don't want to have pass role. Instead, you could have something like pass to service in as a condition. So that's pretty neat, and it's extremely effective if we do this part of the pipeline, run this part of the pipeline where we make this as an open contribution. So people go and make changes to policies, And when they create a pull request, we have this information when given to the approver who can look at this and then approve to make sure nothing. We give as little permissions as possible, and also at the same time we do not give overly permissive permissions. So that was to demonstrate how Access Analyzer works locally, and also how it would during the part of the GitHub workflow. Even now, because we have this announced, let's say deny, because it's a deny, it wouldn't combine it because we're denying it, so that's good to go. So that's how Access Analyzer works. Let's make it okay as it was. Just create access key, create user, and deny. Okay, so that's the source control policy we want. Just to make sure it is as we okay. That's just time to check. So let's go back to our original idea of adding GitHub. Let's add GitHub. Let's commit this as GitHub workflow. Let's add rest of the items. Let's do that. So now we have committed all of the code locally. Let's go ahead and push all of this to one. It's good to go. Let's see. Yeah, so all of this is here. We can, I think, is it already? Yes. So let's log in as the other user and review this. It will not run the check for now. Well, actually, because we have checked this, checked in the code, GitHub workflow. I don't know if it will actually run that. Let's make it check. Yep, it will not run the check for now because we have not pushed the code in. Let's do that. Let's log in as the other user and approve this. So now we have logged in as the other user, who will be the reviewer and approver. So this is how it looks for an approver, for the other user. So it says review required. We say add your review. It lists the changed files because we know what we are checking in. Let's go ahead and approve this. Let's say looks good. Approve. There we go. So it says changes approved. We can actually do this, or I don't know how it's going to look for the other user. Let's quickly check, see how it looks for the other user. So it says, yeah, so Rajesh Khanna dash reviewer, who's this current user, who's used for approving the changes. He's approved it, and now we can actually merge it. Let's do that as the other user and stuff. Well, actually, we can do it here as well, but then let's do it as the other user. So we are here, see the original user committed all of this code, we can merge. Yep. Let's say merge domain, something like that. Merge. Yep. I see this. And now that this would have merged. Yep. So all of the code is here. We're good to go. Now, from now on, if we do any pull request, it's going to Um, this is actually close, right? We can actually also go ahead and delete this branch if we want to. That's deleted. It's good to go. We just have one branch, and all of this code is here. So the next step is to deploy the code to code pipeline, which is the actual pipeline, which will pull all of this code from here and deploy the CDK app. So the CDK app sits here in under stacks. So this is the actual code itself. So this has the code and the policies which we want to deploy. So the actual CDK app is here, which is the service control policies, where we load the JSON policy from policies folder, and we make use of the organization's level 1 construct part of CDK. So we import the organization's construct here, and then there was a recently announced level 1 construct. What this recently announced capability part of CloudFormation to handle policies part of organizations, and we can actually use that in CDK to basically add this as a service control policy, and then we have this as a target ID, which is the account ID, and we also have some commented out in code pieces which we'll enable later once we see how this works. So that is the CDK app itself. The pipeline is actually here. We deploy that here, part of the app.py file. So this is the actual code for creating the CDK pipeline, which will deploy the CDK app. So what we mentioned here is the actual repository, the GitHub repository, the branch, and also the connection ARN, which we have already created under the settings for code pipeline. So which we have already done that. Let's go. We may want to log in again. Let's quickly log in. Settings, connections. So this is the connection we have established with GitHub and the ARN. So we use that connection ARN and trigger the pipeline whenever there's a code push to the repository to this specific branch. And when that happens, what we do is run a CDK synth, which creates the CloudFormation templates and then runs them against the pipeline stage. So we also create a pipeline stage part of the deployment, which will pick up the CDK app and deploy to the destination which we mentioned here, part of the deploy.py. So this is the stage. So we import the pipeline stage here as from deploy.py, add that as a stage here, and that stage has information on where to deploy. So we give the information on the account ID, the region, which also has information. So we've imported the actual CDK app here, so which is the automated SCP stack here. So this is imported from stacks folder. So we have it here. So if we go to deploy.py, we imported from stacks.service control policies stack. We import the class, the automated SCP stack class, and that's the class here. So we define the class here. So with that away, what we do now is assume the role to the account where we want to deploy this. So we do not have a pipeline yet now. Let's go back to developer tools, go to pipeline. We do not have a pipeline here. Yes, so let's do CDK deploy. This will generate what basically CDK deploy does is it synthesizes the cloud formation template, which creates the pipelines. And then because we are making use of CDK, it also generates the list of IAM policies, KMS keys deployed, needed for the deployment. And that's the banner here, which says there may be security related changes, not in this list, but do you want to deploy these changes? We say yes, and then the deployment starts. So if we go to the account, head to CloudFormation, so you see the pipeline CloudFormation is being created. So the deployment is completed. And now if we head back to the console, you see it's already picked up the code from the GitHub repository. And it has begun to synthesize the CloudFormation templates for the CDK app. This also assumes that we have, before we do the CDK deploy, because we should have also done the bootstrapping of CDK. So if we have not done that, the way we do that is for any specific account, in this case, if we assume a role into the account, which has permissions to create KMS keys, policies, and S3 buckets, an admin account is preferred. So if we assume that role as an admin account, go to the assume that role, and then CDK bootstrap with execution policy. So this is a parameter we can pass to give specific permissions for the policy we want to run. In this case, we give the administrator access for the CloudFormation templates, which will be executed in the account. And we can also mention the trust policies part of the role which is created, which will deploy the CloudFormation templates. So in this case, we give, if we want to do cross-account deployments, we can add the account IDs from where we run the actual CDK pipelines, which will assume the account, the role in the destination account, and then deploy the CloudFormation stacks there. So if we run this, because we've already bootstrapped the account, there's nothing much. It's not going to be much changes. Yep. So we've added this policy environment is bootstrap, no changes. And if we go back to the pipeline, we can see the build process is done. Synthesize is completed. Back to pipeline, go to pipeline. It will self-mutate, check for any changes to the pipeline itself. We do not see any policies created yet. It's because the deployment is still happening. So because it's in the same account, there's no assuming of role into another account. It's in the same account to which we've delegated the organization's capability of managing policies, specifically service control policies. So we've looked at that in a different video. So because this is all in the same account, we can actually head to CloudFormation again. You'll see this is the actual CDK app or the CloudFormation stack, which is created part of the CDK app for deploying the service control policy. So this is what we mentioned as a stage part of the pipeline. So this is the deploy service control policies automation stage, which will pick up the app and then pick up the policies and deploy that into the same account. So we do not see the policies created yet. Let's quickly refresh this. We'll have to wait for we see the policy created. This is the policy we've added part of we go to code, stacks, service control policy. So deny actions outside approved regions policy is what we created. It gets created here. And also the target is this account ID. So if we select target, so this got attached to the dev account here. The pipeline would have completed. Yes, so it's completed. Succeeded. What we can do now is to actually simulate a change, as in we can make changes to a policy one or two ways. We can either make changes to the policy here, or what we're going to do is enable the specific piece of code in the CDK app, in the specific stack, which will also trigger a change and also trigger the pipeline. So we go ahead and uncomment this. What we add here is the ability to append or add another policy, which will also be deployed. So we pick up from the policies folder, we pick up the second policy, read that as an object, and we make use of the organization's level 1 CDK construct, input that object, JSON object, created as a service control policy, and attach it to the target OU. So there are two ways, right? Like we can attach it to directly to an account ID, or we can attach it to a target OU, which has multiple AWS accounts in it. So now that we have uncommented that, let's to save this. Okay. Yep. So that's a change. We are still in the review one branch. Let's make use of the same branch. Add stacks, status. So we know this, there is a change. We go ahead and commit. Let's say source code policies. Git status. So we'll go ahead and push this change. Review branch. Yep, let's go. Change. Yep, so this is the change we just did. Create pull request. Let's say added SCP. Leave it blank for now. Yep, file changed as one. Yep, this is a change conversation, comments in run. We have made a small mistake, or rather, I have made a small mistake. We see this pull request should have initiated an action, GitHub workflow, which it did not. It's because of a silly mistake. We have GitHub. We do not have. This should be part of the workflows folder. This should be into a workflows under .github. So we did not do that. What we'll do now is we'll quickly close. This is closed. And what we'll do is quickly this. We will add the workflows folder. Oh, we have it already. Go to get okay. Move the main move to workflows folder. So git status should show that. Yep, we'll do that. What we do is git log, go back one level, or we remove the change we just did. Or we can add it as we want it to. Let's go ahead and, yep, so this is deleted. Let's undo the changes to this file and then check in code, which is the workflows folder. That way, the next time we create the PR, the workflow will actually run. Let's do that. So what we have done is we reset the changes we did earlier. And we'll go ahead and add workflows. So this will add that change. We will push this code to review. And that fails. Let's quickly fix this. So what we have done is we updated the folder structure for the workflow. So we have the workflows folder with the YAML file in it. And we have pushed that as a change to the review branch. And we will create a pull request from that and merge it. Yep, let's do that. Create a pull request. Do get a workflow. Yes, sir. Create pull request. Files changed. Yep, that's what we want. Review changes. We can do that. Let's assume the rule. Because we have branch protection, let's not assume the rule. Let's log in as the other user and then approve this quickly. This is the other user used for approving. There we go. We have the policy validator already running. Oop, we have an error. Well, this is what happens when you want to run a live demo. Apparently, we need to have permissions for this. So let's also quickly fix that. Let's the test. So next time we push changes, we should be 755, right? Let's see what's the current. Yeah, so there's an execution capability. So let's do 755 policy. Yep, that is good. Git status, git add test. Yep, commit. Let's say updated file permissions for this. Let's push that changes now. Yep, that goes through. Now, let's see if it actually picks up again. Yep, it picks it up. There we go. Well, actually it runs. Yep, looks good. Runs the search control policies. Yes. We are good to go. So validates the service control policies. So it runs the test. Yep. We do not have any errors, so we are good to go. And we have the green light here, which actually feels good. So now that we have that, the reviewer can review this. All checks are passed. We can add review. We say this is good, just to keep things clean, true. And we can actually merge this. Confirm merge. And delete this branch. Keep it clean. Oh, the OCD kicks in. So yeah, I'm just gonna review has already merged this. So we have fixed what we did earlier. Well, we still haven't enabled this. So what we do now quickly is, let's do this. Uncomment this. So even now, because we've already posted change, code pipeline would have picked it. And then it will run the same pipeline, but there's not much changes because we changed very minor areas of the code. It will still trigger the pipeline. So, which actually it did not, which is actually funny. Let's see, maybe because we did not make changes. Oh, maybe because we did not make changes to the actual code itself. That could be one. Let's quickly check. Yeah, that could be it. You know what? Let's confirm that with making this change. Let's make this change. Uncomment this. Git status. Git add service control policy. Comment. Git comment. Okay, and service control policy. Let's keep it simple. Okay, and then push this to V1. Yep, and if I create a pull request, can I approve it? I don't know. Let's see. Pull request. Because I'm the reviewer, I don't think I can do it right. So yeah, because I'm this user, I'll have to log in as a user. Oh yeah, so there you go. So valid service control policies is already kicked on, kicked off. So this is the workflow itself, which is already kicked off, which will run the analysis. So search, oh, it's already done. So we're good to go. But we'll have to log in as the other user to approve this change. All right, let's do that. So yep, you've logged in as the other user. We see reviewers push that code. We have a tick here because all checks are passing, which makes it look good. So we go here, checks, validate service control policies. We select the runner, validate. All of this is good. Go back to pull request. We say add your review. We say nice. Did I try it? Submit. Conflicts, which is good. Yes, confirm merge. And we are good to go. Delete this branch. This. Yep. So this is the main branch. Yes, so this is the main branch. And let's see if it actually triggers the pipeline. So what we have done now is made some more changes. Quickly to the README, just to initiate the pipeline. Let's also review this and approve. So we got the approver to approve it. We merge to main. Let's see if it actually picks up. See if it actually merged. Yep, it did merge. So let's try this again. We have this policy already created and attached to this target. So the UI, it looks like this. We have this created, the target is here. We just saw that. What we're trying to achieve now is enable another policy and trigger the pipeline from there. So that's something which we want to try. So let's do that while we merge into main. So let's uncomment this. And comment, yes, sir. Add SCP to restrict users from creating IAM access keys. Yes, let's do that. And also let's push to review 3. Yep, that would have created. Let's do this. Go to branches. We have review 3. Yes. New pull request. Add SCPs. Let's create a PR. Yep, so PR created. Let's approve it from the other user. We have the integration test. also running, which is awesome. We have the service control policies checked, and they're all good to go. Let's approve this. So the other user, I'm just going to review has created the PR. It's fine. We just have another user to review, create PRs and approve. So we can approve this. Much review. It's good to go. Merge pull request. Confirm merge. Excuse me. We can go ahead and delete the branch now. Let's go to code. So we have a merge. Let's see if the pipeline triggered. Yep, there we go. So the pipeline triggered. This works well now. We are good to go. So pipeline is triggered. It creates the build process, which is actually synthesizing the CloudFormation templates. So it runs all of the commands we have specified in the pipeline code. So this is the entire pipeline. So this is what runs part of the code build process, which is it installs the CDK CLI, AWS CDK CLI, installs any of the requirements we have, part of the requirements.txt, which in this case, it's basically installing the CDK library and the constructs which are required for the CDK. So, and after that, it basically synthesizes the code to the CloudFormation templates, which will be deployed part of the next step. So this is completed. Go back to pipeline. Still in progress. It also tries to update the pipeline itself, which is, so this is a self-mutating pipeline, right? So this is the concept with code pipeline itself, which basically tries, if there are any changes to the pipeline, say in case we have additional stages, we've added stages or additional accounts to be deployed part of the same stage, whatnot, differences to the pipeline itself, it goes ahead and updates the pipeline. So it self-mutates the pipeline by itself without the need to destroy and recreate the pipeline. So I'm not sure if with other ISC platforms out there, whenever there's a change to the pipeline itself, if there's a need to delete and recreate it, or we can on the go run it, like in this case where the pipeline is hosted, but the pipeline code itself is in GitHub, and we can update the pipeline on the go without actually deleting the base pipeline stack, CloudFormation stack, and recreating from scratch. So that's a big advantage. So this is getting deployed as of now. We still do not see the policies here. Let's quickly do a refresh. Yep, still do not see it here. Let's wait for some more time. So this is deployed now. Let's quickly refresh this page. Yep, there we see deniability to create IAM access keys and users. This is the policy. We have it deployed to the OU. So this is the illustration of unit, and this is the OU name. Awesome. So now this works. Cool. This is amazing. So what we have done, a quick recap, is we have created this GitHub repository, which will host the code for the pipeline itself, which is the CDK pipe. We make use of code pipeline, which is actually a pipeline to deploy the CDK app, which we have built. It will create the service control policies and attach to specific accounts. And that CDK app is also part of the same source code base in version control in GitHub in this repository. So we have that policies here as JSON files. And the CDK app itself is as a stack here, as a class, which we will import into our pipeline stack later on. So we have defined this. If we want to extend this and build over this, all we have to do is create the policy in the policies folder, create a JSON file, and append or add information here with loading the JSON file as an object here, and invoking the construct here, which is for the organization's construct, the CFN policy, which is a level 1 construct, and then given the data necessary to create the policy as a service control policy and attach it to the target OUs, either OUs or account IDs, and then merge it to main, push the code, create a PR, push the code. Because we have branch protections, but you can do it the way you want it in your organization. Depends on how we want to do it. The way we've done it here is because we have branch protections, we want someone else to actually review code, and also meanwhile we have this capability to have actions. Is we make use of GitHub Workflows to review the policies, the service control policies, using AWS's Access Analyzer. So we give that manual, or there's an intervention where someone can actually view the results from the Access Analyzer run validation. So someone can actually check this and then approve it. If someone, there's this very neat little integration here, which is actually nice if someone actually reviews this and merges this before it gets pushed out. That's pretty much it. Let me know if you have any questions, comments, suggestions. Thank you. Take care.